Assalamualaikum students. So this is a video tambahan from the first part because it seems that the slides did not change while I was doing the lecture. So this ni part yang the missing part Okay, so for this slide I want to show you the sampling, the effects of sampling. So I'm showing you through images because it will be more intuitive and easy for you, hopefully lah, easy for you to see what happens when we do sampling. Okay, so we take an image of that is of the size 256, okay, by 256, okay, maknanya 256 rows dia 256, and let's see, can I find my pen here? Okay, so the row is 256 and okay, the row is 256 and the columns also is 256. Right, so this bila kita buat sampling, alright, sampling, remember sampling happens at the x-axis, so at n. So here when we do sampling, that means we take certain numbers of pixels only. So bila kita, so from 256 to 256, when we take just a sample of these pixels, so kita akan change, katakan to 64 to 64. So size dia, row dia dah berubah, column dia dah berubah. Okay, so you see that this image is more pixelated. Walaupun tak jelas, you get the idea of the original image. Okay, so it's similar to sampling dalam signal. So you see that from the continuous signal kan, when we have a continuous signal, okay, so you take a sample of this signal, okay, right, so you take a sample. So when you draw a line through this titik-titik ni, so you see that it becomes the original signal again. Okay, so that is sampling. Okay, now I want to show you quantized image. Okay, so quantized image, we take again the 256 to 256 punya image. Okay, dekat sini you nampak ada 256 punya levels. This is referring to the grayscale. Grayscale. Okay, grayscale level, which is from 0 to 255. Okay, so this is the intensity levels of the pixels, the values of pixels. So daripada sini, this is similar to xn. Okay, xn. Now we want to reduce this the range, dia punya range levels ni, okay, intensity level kita nak kurangkan. So bila kita kurangkan, kecilkan sikit dia punya levels, okay, kepada 32 levels sahaja. You see that dekat sini, alright, the image is clearer, okay, because some of the intensity tu kita dah remove, and it happens that the intensity levels tu are noises. Okay, so that's why kalau you tengok betul-betul lah dekat slide ni, okay, you can see dekat slide yang saya bagi dalam PDF tu, I think it's much more clearer that the image is much more clearer than the original image. Okay, so especially some blurrings dekat sini, ni dah semua dah start to clear up. Okay, so when we reduce the levels, okay, so we remove some of the xn. Okay, now what if we reduce further? Okay, this level kita reduce further, you rasa akan jadi lebih clear ke? Okay, so kita tengok if we reduce this further, okay, 256 to 256, you see that the image is, we can still see the image, but it's not as clear as previous image, because level dia dah jadi 2 levels only. So 2 levels ni maknanya kosong dengan 1. So 0 is black, okay, and 1 is white. So means that tadi you remove levels and it removes some of the noise. Now you remove more levels, it reduces more of the signal itself lah. The intensity, intensity. Okay, but this is on image. Alright. So, a discrete time signal may be a finite length or infinite length sequence. So, finite ni means that dia ada duration yang tidak terlalu tidak sampai infinity, okay? Now, infinite length obviously with dengan nama dia pun kita tahu infinite, ya. So means that dia punya duration tu is from from negative infinity to infinity. Now the finite duration is between n1 to n2, okay. So bila kita nak okay, gambar ni bergegar sikit because I cannot find my tripod in the wee hours of the morning, ya. Lori sampah baru lalu tadi. Anyway, okay, so the length or duration of a finite length ni kita boleh dapatkan dengan menggunakan formula yang ini, okay. Right, so bila kita dah guna formula ni, so let's say we have a signal, okay, and then we have a signal, this is xn. Okay, xn. So you have 0, 1, 2, 3, 4, 5 katakan, ya. 1, 2, 3, 4, 5. Right, kalau kita tengok ni length dia pendek je. So kita tahu ini adalah 6 sampel saja. But okay, if we use this formula, you see that dia adalah 5, okay, 5 tolak 0 tambah 1, so dia jadi 6. So 6 sampel. So kalau kita nak tengok daripada sini je kan, sini, okay. So kita tahu ini ada 5 sampel saja. So kalau kita guna formula yang sama, 5 tolak 1 tambah 1 means dapat 5. So 5 sampel, betul lah. Okay, so we don't use this formula in this method lah, because you boleh kira visually. But if you have a very long sequence, yeah, then you should use this formula, okay. Now a right-sided sequence has 0 valued samples, okay. So dekat sini, if you see, right, okay, right-sided sequence has 0 value at n smaller than n1. So basically right-sided sequence ada value, okay, right-sided sequence ada value, okay, left-sided sequence tak ada value, tu saja, okay. But kalau kita tengok kat sini ada causal sequence kan. Okay, so causal sequence adalah bila n1 is bigger or the same as 0. So if n1 is 0, then this is a causal sequence. If n2 is katakan 2, okay, this is also a causal sequence. If n1 tadi, n1 is 0 is a causal sequence. Kena apa pula ni? Okay, n1 is a causal sequence. Bila n1, sequence is causal when n1 is 0 or n1 is 2, katakan, bigger than 0 or the same as 0. If n1 is equals to negative 3, katakan, so it is smaller than 0, so it is a right-sided sequence. So this is a causal sequence, this is a causal sequence, this is a right-sided sequence, okay. Now, a left-sided sequence is obviously the opposite of right-sided sequence. So basically you ada here dekat sini, okay, right-sided sequence ni semua kosong, left-sided sequence ni ada value. Okay, so again sama juga, N2 bila dia sama atau lebih kecil daripada kosong, it is an anti-causal sequence. So if N2 is 0, then it is anti-causal sequence. If N2 is -2, it is anti-causal sequence. If N2 is 2 saja, then it is a left-sided sequence. Left-sided sequence. So this is anti-causal sequence. This is anti-causal sequence. Okay, this is right a left-sided sequence. Okay, left-sided sequence. Right. Now, types of discrete signal. There are two basic types of discrete signal yang you kena ingat dan tahu, because these are the signals that we use as selalunya as input. So dekat sini, impulse signal is represented by delta n. Okay, delta n, and it's just one value saja pada n equals to 0, dan value dia adalah 1 saja. So one pulse at n equals to 0, and value xn dia adalah 1. And step signal pula is represented by un ataupun mu n. Mu n ni dipanjang sikit dia punya ramos dia. Okay, so you have mu n. So mu n is an infinite length sequence. Value dia xn dia adalah 1. Dia start daripada 0 hingga infinity. Okay, so daripada 0 hingga infinity, okay, value dia 1. Alright, that is a step signal. Okay, so that's the missing part. I hope you can follow. And then if you have any questions, don't hesitate to PM or DM me, or you can ask through your class rep, because the reason why I ask you to ask through your class rep, because class rep you akan share the information to all of the students, to all of you. So sometimes you tak terfikir soalan tu, bila kawan tanya, oh ya, I pun terdetik tapi tak tertanya. Okay, alright, thank you very much.